In this video, we're going to talk a little bit about the Advanced Manufacturing Education Initiative up in Greenville, South Carolina, specifically focused on the idea that we have cohort and small class sizes. So this is an example of the 2019-2020 Advanced Manufacturing Cohort. The students gathered together, took classes up in Greenville in the fall 2019 and the spring 2020, including classes on design for manufacturing, teamwork in manufacturing, additive manufacturing, digital manufacturing, in addition to core mechanical engineering senior classes. As an example of the cohort, we had small classes that were taught by two lecturers exclusively funded by the Center for Advanced Manufacturing, in addition to faculty from main campus. We had crossover projects spanning classes in design and manufacturing. We developed industry network through tours and speakers, and the cohort itself was reinforced through shared offices and the common classes. These are some of the examples of students that have graduated from the program, with many of them continuing on to graduate studies here at Clemson University with various faculty advisors. The program, as an overview, includes courses that are focused on advanced manufacturing. These courses include projects that span and reinforce and integrate concepts. The industry network is reinforced through weekly factory tours where the entire cohort travels to a local company to spend the day touring and talking to the engineers and associates at that company about the current state of the art, their challenges, and their needs. Using this, many of the students have defined their master's thesis topics. Additionally, students can start graduate school early. If they have a 3.0 or better, they can put in an exemption request to start their BS/MS program. We have dedicated lab space for advanced manufacturing and prototyping that students have access to for both classes and for their personal interests. Finally, we have established a professional environment, such as students being granted their own desks and cubicles, and a workplace that mirrors and mimics that of industry. Here are some examples of some of the curricular activities. We see an assembly line where students designed and put together a Lego assembly line as part of their teamwork and manufacturing class. In addition, other students in the class performed teamwork observation studies. In this way, one activity served two different purposes. In the design class, a required class in mechanical engineering, students had an external client, the career workshop, for whom they developed a memento. They designed this coaster, including packaging, and then in the manufacturing class, they developed the assembly line, defined all the manufacturing processes, established quality and inspection protocols, and produced 300 units delivered to the company on time and under budget. This is the first time that a manufacturing class at Clemson University developed a complete production line and executed it. The curriculum is structured so that it is exactly the same in terms of core content as the traditional flowchart in the mechanical engineering program. A few courses are shifted from the senior year to the junior year, such as arts and humanities electives or social science electives, and some of the mechanical courses are shifted to the senior year, such as machine design and manufacturing. There are lots of options that are now being introduced in terms of technical electives that students can customize their manufacturing program in Greenville. As an example, 3 technical elective courses are planned for the fall 2020. They include Global Manufacturing, Metrology, and Teamwork in Manufacturing. The Global Manufacturing class, taught by Brian Riley, explores topics and issues faced by companies in distributed manufacturing that include supply chain, regulatory, cultural, and economic factors. This class will have a bridging project with the manufacturing processes class, also taught by Brian Riley, where students learn about manufacturing processes and they also plan and execute a manufacturing production line. That manufacturing production line is through a shared project with the design methods class taught by Geeta Shimada. In this class, students learn how to systematically apply a design process to develop a product for the external client. In addition, the Global Manufacturing class is planned to have a project that discusses the teamwork aspects in cultural impacts for distributed teams. And that project will include students also from the Teamwork and Manufacturing class. The Metrology class will focus on geometric dimension tolerances and measurements, and it will include some in-class measurement activities that will be used to reinforce projects associated with the machine design class, also taught by Geeta Shimada. The 2 lecturers both have industry experience. Brian Riley comes to Clemson with 29 years of industry experience, whereas Geeta Shimada comes with 3 years of industry experience. If you have more questions, please feel free to contact myself, Josh Summers, or Brian Riley, Geeta Shimada, or Mark Johnson.